Today I will be explain the Neumannian boundary condition. Explain the Neumannian boundary conditions. Explain the Neumannian boundary condition. Neumannian boundary conditions by means this is the one more name is calling about natural boundary conditions. Natural boundary conditions. The value of the gradient of the dependent variable is specified. What is meaning by the gradient by means, for example, you have in a temperature gradient, you have in a pressure gradient, you have in a velocity gradient. This is calling about the gradient. Example, k into dou t by dou x. One more, this is q equals minus k into a dt by dx. This is the Fourier law of heat transfer. The q by a minus k into dt dou t by dou x. This is the partial differentiation terms. This whole terms is calling about q, small q is equal to minus k into dou t by dou x. See, this is calling about in heat flux. This is the small q is equal to heat flux. See, you have, when you go for the real applications, T equals Ts and small q equals the heat flux. This is the diameter d. This is the diameter d. This is the length L. See, a rod of dia d and length L, where at x is equals to L and q equals to heat flux. Is specified. This is calling about explain the Neumannian boundary conditions.